Today I'm talking about leveraging machine learning algorithm to sort out defect parts from the production line. As you know, in the production line, normally there will be some defect parts, and traditionally those were sorted out by labor. But however, during the COVID-19 pandemic and around the world, it is experiencing the labor shortage and also the rising wages. And human also produce inconsistent output, and this is the problem that the business is facing. And we can use the classification model such as KNN to detect the faulty part. And as a result, the cost will be significant lower, and because it is only one time setup cost, and the result will be more consistent because it is more automated. And so the target user, of course, is the factory in production line. And just now I mentioned about the inconsistent labor supply, and also the fault detection result is inconsistent by human in the production line. And this normally is either causing the production output limited or reduce margin if the false positive or false negative is too high. And in terms of the device size, and we can from in terms of the output, and we can improve the cycle time by let's say 10 seconds. And output metrics, and for me it is more important is the false negative should be lower than a certain percentage, because if the false negative is too high, and the quality will have a significant impact. And the constraint is the production, because this is automated setup. So the it require this whole system will operate in the control environment. Another constraint is that the faulty part, the type of faulty part should be known. And what is the important factor for this model is the part, or especially the 40th part, the size, and also is the shape or weight, or even color. And when talk about the validation plan, and first of all, the machine learning concept we can leverage with the classification model, for example, the KNN. And the first step is to find out how many uh, faulty parts type this system is going to detect. And in other words, we have to define the K clusters, the number of the clusters we want to clarify. And the other is the in terms of the training, we can use the 70% of the training model of the data set to train the model, and another 30% to test the model. And for the machine learning system design, and this is the edge overclock. Because of the low latency requirement, this is more like real time. And so as a result, the online prediction is more preferred because it is a real time system in the production line to detect the faulty part. And in terms of the training, the offline learning is more preferred. And in terms of the potential risk in the production, the overall risk level should be low, because this over time, and the type of the faulty mod lines will be consistent, and the data will not drift, and the concept will be the same as well. So the overall the risk level is low in this scenario. And but potential disadvantage is that this system is more sensitive to environment. And for example, we the whole system have to be in the totally controlled environment. And the for example, the lighting may contribute some of the false detection as well, if the light that is not controlled well. Yeah, so that's it. Thank you so much.